Um, Hi everyone. Thank you for joining in. Thank you Sudhanshu for inviting me. I was very surprised when you DM'd me. It was totally unexpected. Um, so yeah, what are we sort of going to be doing today, right? So there are two main things that we're going to be doing. Talk is divided in two main halves. The first one is exploring the .git directory that Git creates when you initialize the repo. We look into the files and directories there. We'll see why are they needed, what's going on in them, what's the structure of each file, and that kind of stuff. And the second thing we're going to be looking at is Git objects. So Git uses certain objects to sort of manage your repository and do its version controlling stuff. So we'll see how it does that. We'll take a few scenarios and we'll create directories. We'll see how it manages directories. We'll rename files. We'll take up huge files and see how Git efficiently manages that. So yeah, again, if you're noting down anything or writing down anything, please don't. I have stuff written down for you. Everything that I'm going to be doing is already written down, so I'll give that to you at the end of the session. So yeah, just have fun. Please ask. I'll be waiting for question answers like quite frequently, so feel free to ask your questions. I might not be able to answer everything. Also, if I make any mistakes, please let me know. Um, I've been having fun with this as well. So yeah, just let me know if I make mistakes and feel free to pitch in if I'm wrong or something. Okay. So yeah, without further ado, let's start. I start by presenting the screen. So yeah. Okay. So basically, we're going to be on the command line for most of the talk session. So yeah. Okay. Um, okay. Let's create a folder here. Um,
But, just increase your font size. Means like
Yeah,
just do
sure.
yeah.
Is this better?
Yep, this is better. Thanks.
Um, let's see. Oh, my bad. Let's get into another folder. Okay. cp internals. Okay. Yeah, let's just, by the way, I'm assuming that people here know certain stuff about Git, such as Git add, Git commit. Um, you know what is the staging area, you know what is committing, you know what the working directory is. So if you don't know any of these terms, just let me know. I'll explain that in short to you, because that is basically what we require for today. So anyone not knowing what these terms are, because I am assuming this much level of uh, comfort with Git. Okay, fine. Great. So yeah, let's just initialize the repo, git init. Okay, now I'm sure you're aware Git creates a hidden directory known as .git. Okay, let's get inside it and see what it has. Okay. Oh, my bad. Why did I get it? Yeah. So now let's just list everything. Okay. So we're going to go into everything one by one. Okay. So let's start with the easier ones first. Okay. So this description file, right? For now, this file is not. It will not have anything inside it. I just have some commented out stuff. Oh, I misspelled it.
CD description.
Okay, yeah. That's what Git is
CD
telling me. I'm
description.
sorry. Git is telling me that yeah, the repository is unnamed and this file is like I need to edit this, but this file basically, this direct description file is basically is not used that much now. It was used in days when Git itself provided a GUI known as Git Web. Okay, so that is when you used to write your repository description here. Nowadays, local repositories don't really require that. So this file is where you can add a repository description, but it's not really of any worth. Okay. So this was of the days of Git web. But anyways, moving on, hooks. This directory is again not something we're going to look into today, but let's just see what it has. Okay, I went in the directory. I'm just going to list all files. So if you see these files, so hooks, if you know what hooks are, hooks is basically if you suppose if you want to create some commit in your repository or something, but before that you want to have certain checks that hey, has this person, is the file linted properly, is the file formatted? If you want to run something like prettier before committing, so you can set up a pre-commit hook here by saying that hey, whenever someone does git commit, I want you to run this particular program before before committing it actually. So that's why you can run something called a pre-commit hook and that kind of stuff. Okay, so hooks is not something we're going to look into, but you can write these scripts wherein you can run commands, run commands at certain things when you're rebasing before pushing. You have certain checks that you can make, and it's completely up to you what you want to do with these. Okay, so not really something we are looking into today. So just letting you know that it exists and what it is. Okay, oh, I need to go back. Yeah. So that was the stream, that was hooks. Now info. Info is again, let's just get into the directory. Info and now ls. So the info directory has just one file known as exclude. What is this file? It's basically your git ignore file. Okay. But there's a difference. Okay. So anyone here who doesn't know what a git ignore file
Yes, there is a question that do hooks is hooks are committed to Git
I'm not really
yes,
sure. I
yeah.
have never experimented with hooks.
Yeah,
So
so I can elaborate on that question, but
sure.
would be keen to know if anyone else can add. So, do these hooks get committed into the repo for other devs to pick up as well? Because there's two preferences that devs usually carry. One is my personal dev setup. I don't want this to go onto the repo. Would be good to understand that. Looks like a very interesting feature. Wasn't aware of that.
So I can answer on that. Git directly, the hooks are not committed itself, but there are tools you can set up to use to set up those Git directories. So basically, there is a Husky tool where you write your pre-commit hook in a different directory, and those files are copied into your Git directory. So .git folder is not synced, but you can your scripts will make all the scripts available there for everyone.
Perfect. Perfect. That answers it. Thanks.
Got you. Um, so yeah, the info. So yeah, I'm assuming everyone here knows what Git Ignore stands for. So Git Ignore, whenever you add something in Git Ignore, it safely ignores your file and it doesn't push it. It doesn't commit it or push it, right? So this exclude file inside info inside the info directory. Let me just open that up for you. Bin exclude. So yeah, it has the same syntax of the git ignore file. Okay, so what this basically is your local git ignore. So for example, if you want to ignore a file in your, suppose you have a to-do file, right, in your repository, and you're like, okay, I don't want to add this to .git ignore. I don't want to add it for all other developers out there, right? An entry like to-do.md in your git ignore file might cause problems for some other dev or something, right? So you want to have one file like a to-do file or something that hey, these are the steps that I still have to do, and you don't want to add that to git ignore, but you still want git to ignore that file. You can add it to this exclude file here, right? It has the exact same syntax as your git ignore file, but it's just for your local repository. Those files will never appear in the git ignore file, nor will they appear in any commits. So yeah, that's the use of the info directory, and that's why we use the exclude file for. That's what we use the exclude file for. So yeah. Um, and so description hooks info done. Now objects. Before we get into that, so this is basically the most important directory here. All of your interesting stuff happens in this directory, right? Your Git objects. That's the main thing. So let's ignore that for now. So we're going to get into head and refs now. Okay. So for that, I'm going to use another repository because that will explain it to you properly. Okay, great. So now let's get inside the, so this is another repository called Git Basics. Let's get inside the .git folder here. Okay. And if we list all the files, let's check this head file here, right? We were supposed to check head and refs, right? So let's check this head file here. Okay, let's see what it has. Let me cat it out. Okay, so it's saying, it's giving me a reference saying, okay, go to this particular file, ref/head/main. Let's see what exists over there. Okay, let's go to, cd into refs and cd into heads and list everything here. Okay, so there's one file called main here, right? Ref/head/main. So let's check what this main file has. Okay, it's a file, not a directory. Let's cat that. Okay, it gave me this string here, right? So if we run git log, okay, git log, let's see what that outputs. Okay, so if we check here, this is the latest commit in our repository, right? So this and this string matches, right? And if you see here, you can see your head is pointing here, right? So basically, this head file here, every repository will have this head file. So this basically points to the latest commit in whichever branch you are in. So right now in the main branch, okay, it's green in color. So the head is pointing to the latest commit here, right? So the head has a reference to the latest commit, right? So now we need to explore this refs directory, okay? Because apparently this had the main file, right, which had this reference to the latest commit. So let's check out this refs directory. Okay, so we are in heads right now. Let's go back. Okay, so we are in the refs directory. Let's just see what all it has. Okay, so okay, heads, remotes, and tags. Okay, let's check it out. So as we saw, heads has the main branch. Now let us check out what remotes has. I'll get into it. Just give me a second. Okay, it is origin. Okay, let's get inside origin. What does origin have? Okay, it again has a head, it has DH pages, it has main, and it has image bot. Okay, so I think you're understanding what's going on. So refs is basically references, right? So they are storing, so this particular directory is basically storing references of the latest commits in each branch. Okay, suppose you have 4 or 5 branches, so this directory basically stores references to the latest commit in each branch. Because when you're switching branches, you need to have some, your Git needs to know where to go, right? Where the head should point, right? Because the head is basically what is telling you that, hey, Git, here is where the latest commit is for this branch, right? So Git needs somewhere to store it, right? So so it shows in the refs directory. Now in the refs directory, as we saw, there are 3 folders, right? So heads is basically whichever branches exist in your local repository. Okay. And remotes is the one, are the reference to the branches which exist on your remote repository, right? And so whenever it wants to fetch or something like that, it'll check out, it'll check out stuff here, right? And then if you have some tags in the repository, then it'll check for the tag objects as well. If you have versions, if you released versions of your software and created tags using the git tag command, they'll all be stored over here, right? So I don't have tags in this repository, so I can't show it. But yeah, so basically, what did we sort of understand, right? So if we go back, right here. So we finally seen, description hooks info. Then we've seen head. Head is basically a pointer to the latest commit in whichever branch you are. Okay, it has a reference to a file, right? So and all those files are stored in this refs directory, right? So this repository, this internals repository is an empty repository, right? It doesn't have a reference to anything right now, right? There's no commit, there's no file, there's nothing, right? So if we cat head for now, um, it will still point here. Okay. Now if we go and check this file, okay, let's see where this points to. cd ref/heads. Okay, and let's cat ls. There's main here. Okay, so see, there should have been main here, but it doesn't exist, right? Why does it not exist, and why does it exist here, right? because whenever you initialize a repository, you have a default branch, right? So my default branch I've configured to be main. You might have it. If you've not configured it, it might be master for you, right? So whatever is the default branch, it'll point to that. But once I create a commit, and I'll show you this once I create a commit, there'll be a main file over here. Okay. Right now it doesn't exist because there are no commits. Okay. So this was basically all these files. The only one remaining is the config file. Okay. And we yet to get into objects, but that's the interesting part. So let's save that for later. Okay. Let's get inside config for now. Let's see what config has. Okay. Clear list. Yeah. So config is also a file. Let's see what the file has. Okay. So again, here, this is your, if you remember, there's a command called git config. So usually when you install Git for the first time, you run a git config command, but that's the global command, right? You run git config global and you add your username and email. So that's configuring your global Git settings. But if you run git config local and you run some command, then that is you're affecting this particular file wherein you're configuring your local changes. Okay, local configuration of Git. Now, I've not really explored all of these, but one of these commands that was really helpful. I mean, knowing what I mean, exploring the internals of Git helped me out in one way was that. So what happened? I got a pull request on one of my repositories, and they had named this image file as full caps gsoc, right? Full caps GSOC. So I was like, hey, I don't like this thing. So I got it, I pulled it, and I changed the case from full uppercase to all lowercase, right? All smalls, GSOC. And then I pushed it along with other files. But the problem was that the changes didn't reflect there, right? So I was like, what happened? Why did the changes not reflect? I renamed the file, right? So apparently, I remember that, oh, by default, Git ignores the case of the file, right? So that's when I realized, oh, I need to turn this false, right? So that was one interesting situation. I was like, oh, damn! I thank God I explored that. Otherwise, I would have to look. I'm sure Stack Overflow would have told me immediately. But yeah, that's how I resolved that thing. So yeah, so that is basically what you change here, all the local repository configurations. Okay, this won't affect other repositories, obviously. So yeah, that's your config file, and it also stores your origin, all the aliases and stuff here. So I'll just show you this repository, the Git basics repository. If you list down, there should be config file, cat the config file. Yeah, we have the C here is false, right? It goes in Git basics only, by the way. It's by default, it's true, but for Git basics for on TR, I had to turn it false. But yeah, so point is, yeah, see, your
there is
alias is your,
so sorry.
sorry.
There is a question. What does Simlink means?
So sim links are symbolic links. They are basically used to link. So I have a sim link. I'll show you. I created one in Windows. This PC C drive. Where is it? Users. Yeah, users. Yeah, so if you see here, this Hush folder directory here is a symlink. So for some programs, what happens is that they don't like this space in between here, right? So what I did, I created this symlink here. What this does, it redirects. So it should just find Harsh, and this link here redirects me to this folder itself, right? So symbolic links are basically used to redirect. It's basically linked to another file, right? So you can redirect someone to Harsh, and I'm like, okay, when you reach, if someone is looking for Harsh, then please redirect them to this folder. So that's what a symbolic link is. Symlink. That's the short. So
what
yeah,
I meant to ask is, what does it mean to have it turned on and off in the
uh,
config?
I don't really know. I've not explored
So
that.
I'm assuming like in a Git, if you have a Simlink file, then whether to ignore that or not. Like so here, if you
Oh,
say
yeah.
Simlink's true, then it will keep it. It will maintain the Simlinks.
Yeah, seems logical. Yes.
Would perhaps mean that it will version control the symlink.
Version
Yeah.
control, it will just yeah, keep it on your. You can stage those files.
Yeah, exactly. So yeah, it stores your aliases here as well, and it has your local config as well. So yes, that's the config file for you. Okay. Now we still not explored the objects directory. I know. We'll wait for that. Okay. Before that, there are some files here, right? Let's explore them first. So commit edit message, right? So if you remember, whenever you do the git commit command, you just say git commit and -m and you type the message, right? But if you know that if you don't write this -m, if you don't write the message into the command line, it opens up a file, right? So which file does it open up? It opens up the commit edit message file, and here is where you write your commit message, and you save it. And when you close the file, it is like, okay, I've got the commit message, and it extracts it to this file. So for now, let us just scat and look at what it has inside, right? Um, let me open it again. So yeah, I think right now it has the last commit message here, but yeah. So yeah, yeah, this is the last commit message. So yeah, if you just write git commit, it will open up this file with some comments and stuff like that. So yeah, I'll show that to you in when we start doing stuff here. Okay, so yeah, that's what the commit edit message file is. And we saw head, rebase head. We're not getting into rebase and merging today. So yeah, description, hooks, info, objects we still have to do. PID, don't worry, it was for GitWeb. I was trying to experiment with it. I unfortunately couldn't set it up. Fetch head, right? So if you ever fetch something from remote, you must have seen stuff popping up. I'll show you. Add fetch head. Okay, so if you see here, it is basically telling me which was the last commit which you had pulled, and so it gives me the hash of that commit. Okay, and it also tells me, hey, this was the branch, because it was the main branch and not the GH pages branch, because obviously it's mentioned here, right? So yeah, your fetch head is basically telling you like, hey, fetch this branch, right? So if I just say git fetch, if you pch origin and main, um, it should change it up. Yeah, so see, it always modifies your fetch head, right? So if we check our fetch file again, yeah, so see, it updated this. So this was the last reference it had, but it updated it with the latest one, right, when I fetched it. So yeah, that is basically what the fetch head file is used for. If you just run git fetch origin, it will fetch all the branches and add this not for merge thing. But I mentioned the branch here. That is why that's the only branch listed here right now. So that's your fetch head file. So it is the head, but the fetch one, right, from the remote repository. So yeah, similar concept as the head file. So that was your fetch head. Then orig head, right? So let's just cat it out. Let's see if it has something in it. I'm not sure. Yeah, it does have something. So if you notice, and let me do big log, which is the latest commit here. So latest commit is cd something, but this still doesn't have the latest commit, right? The latest commit is cd something, but this is f8 something. So what is this file, right? So this file is not really used that much now, but the use case for this was that if you make some destructive change in your repository, right? The last destructive change that you make, something like maybe resetting your repository or something like that. So whichever commit that is, it will store that here, right? Now that we have git reflog, this file does not matter as much, right? But initially we used to have this. So this file doesn't store the immediate last commit. It stores the last commit wherein you have made a destructive change. Okay. So if you just add a file or something like that, like here it's not there. So it must be pointing to some other commit. I'm not really sure. Yeah. It's pointing to some older commit, right? So yes, that's what the orig head file is for. It points to an older point in your the latest point where you've made a destructive change in your repository, right? So that's your orig head file. Let me just clear everything again. Yeah, so commit message run. Yeah, you're here, right? Yeah. Config I showed you. Git web is not. We're not getting into that. Index again, very important file. Very, very, very important file. So the git. So this index file basically is your staging area, right? This one file is so important. Like all your Git add stuff happens here, right? All your merge conflict stuff and everything is tracked here. So also one thing to note in Git, stuff like staging, caching, index, and all those things, and adding, all these terms are used synonymous with index, right? With adding. So yeah, just keep that in mind. Yeah, let me just get this file for you. Cat index, right? Gibberish, gibberish. But we can make out a. I'll don't worry. Yeah, I'll show you. Okay, but we can make out a few files here and there, right?
I,
So
I
yes.
think you can do git
Yeah,
cat.
yeah, yeah. I know. I'm getting to that. I'm getting to
Okay.
that. So you can actually like, sure, if you just carry it out, it's gibberish. But there is a way to sort of see what it stores. There's a plumbing command. So now, what is a plumbing command, right? So Git has two types of commands: plumbing command and porcelain commands, right? So imagine a wash basin in front of you. Yes, a wash basin. Um, so so when you're just standing there looking at it, you see a nice porcelain bowl in front of you with a tap and stuff like that, right? So it's basically what you see on the outside. And then when you look under the basin, you basically see all the plumbing and stuff, right? So that's basically connecting the water and all that stuff, right? So that's the same with Git, right? So the porcelain commands like git add, git commit, git fetch, git merge, right? Git merge does a git pull. Yeah. So git what is it? Git pull. Yeah, git pull. Sorry, git pull does a git fetch and a git merge internally. So all these commands are high level commands. So those are called porcelain commands. But the low level commands are known as the plumbing commands. So the examples can be git rev parse, git cat file, git ls files, git verify pack. There are loads of plumbing commands in Git, right? So we're going to use all of the ones I told you right now. I listed right now. But yeah, so one of the ones we're going to use right now is called git ls file, and we're going to access the staging area, right? In the files, I think so. Yeah. So oh, so many files, my god. Yeah, there's a huge repository. But anyways, so yeah, this is what your index file has, right? The index file is your staging area basically. And I'll go over what these things are, right? So this is known as the mode of a file. Okay, I'll explain that to you. This is the SHA, okay, the hash, SHA1 hash. This is called the what is it, commit slot. Sorry, stage slot, yeah. The stage number or the slot, it's called the stage number. I'll tell you what. So this can range between 0 to 3, 0, 1, 2, and 3. Okay, I'll explain the use case. Give me a minute. And this is the part of the file. Okay. Now let's get into exploring into each of these, right? So this is basically called the mode of the file. This is an octal number. Here, the first three bits, the first three numbers, not bits, first three numbers indicate the first two numbers actually. The first two numbers indicate which type of file is it? Is it a Git link? Git links are used in Git submodules. Don't really have much knowledge on that. Don't ask me about Git links. Then the other type is Simlinks, as I told you, and the third type is our normal files, right? So that is what the first two bits sort of indicate. Okay. Then the this third number here, this is not used as of now. It's always going to be 0. Okay. Then these last three, these are the Unix file permissions, right? The ones which you change with the command called chmod, right? This is the file permission. And if you remember, sometimes this happens. I don't know if you encountered this. This has happened with me. I pushed a shell file on GitHub, and I was trying to run a GitHub action using that shell file to build something. And GitHub action was throwing an error that, hey, you no access to this file, no permission grant, that kind of stuff. So what I had to do, I had to change the permissions of that file using chmod locally, and then I had to push it. So then it had execution permissions, right? So yeah, I don't know if you encountered that, but I have encountered that twice, I think. Yeah. So this is the mode of the file, right? First two for identifying which type of file. Third one is third number is unused. Last three are for file permissions. This is the hash of the file. Now this number, right? And this is the part of the file. So this number, this is called the stage number or the slot. Can name from 0, 1, 2, and 3. Now, where is this used? Right. So this, I have a demo. Yeah, I have a demo for you for this as well. So yeah, let's just go to this again. C coding/git. Yeah. I'll increase the font. Yeah. So there should be. Oh God. CD. very merge conflict. Yes. So we were exploring which file here, the index file, right? And that's what we were doing, right? Using git ls files, we were exploring the index file. Let's do the same thing here. This is another repository, right? So git ls files hyphen stage, right? Okay. Oh, ls files, my bad. So now if you see here, there is 1, 2, 3, and then 0, 0, right? What's going on, right? So here everything is 0, right? If you see it's scroll to the bottom, right? Okay, let's open this in VS Code. Let's see what's going on. Okay, so if we see file C and D here have 0 in front of them, and file A here has 1, 2, 3 in front of it, right? So if you see this, I think you understood what's going on. So just give me a moment. You need to find the exact name for index file. Yeah. Okay. So basically, yeah. So if you see C and D are fine, A added files, okay, 0. So 0 basically indicates a normal file, okay. There's nothing wrong with this. This is an unconflicted file, right? Normal file. But when there is 1, 2, 3 or something, so that's basically Git saying, okay, there is a merge conflict here, right? So we need to handle this merge conflict. Now, how do we do that? So what Git does internally is that it uses 1, 2, and 3 to indicate different states of the same file, right? So 0 stands for I'm reading this by the way. 0 stands for a normal unconflicted file, okay? That's C and D for you, okay? Then 1, so 1 indicates the base, right? The original version of the file. Um, 3 indicates the incoming changes, right? And 2 is basically what you can see here, wherein it has both changes, right? So Git uses this index file as a staging area and to indicate whether a file has a merge conflict going on, or is it a normal file? Are there no merge conflicts going on? Okay, and these are different states of merge conflict, where 2 is the one you actually see with all the changes. And once you edit this file and you commit it, and when you add it and commit it, and then you are resolved with it, and then A will also become just a single entry with 0 written in front of it, right? So that's why you have to add it and then commit it, right? That's the entire thing. So yeah, that's the index file. Very important file. It's the staging area of your repository. It's also the place where Git uses to understand whether there's a merge conflict or no. So yeah, that's an index file. Okay, I can safely close this, but yeah, CLS, okay. Yeah. So, so first row is done, objects is left, I know. Second row we're done with index. Again, now logs, right? So let's get inside this. I'm sure you understood what this is, but I am sure, right? So again, right, we have this head and we have this refs, right? So let's explore head, right? It's a file. Let's cat head. Okay. Oof, that's a long file. Yeah. So yeah, if you see this file, this is basically these are your Git's logs, right? So when you run Git reflog and stuff like that, how does Git know what have you done, what's going on? So basically, this is the head file. So it tracks whatever you're doing, what has been the movement of your head and what's going on. Has the head been incrementing, or has it been switching from one branch to another? Have you been cloning something? Have you been resetting the repository? So apparently I got this repository by cloning it. So yeah, that's the so 000 stands for that, first commit, no parent, that kind of thing. Okay, so this is the first commit, right? So that's basically your what do you call it? Git basically tracking that, hey, this is the current commit, this is the next one. So if you notice here, D4F28 is yeah, again here, right? So DA91. So in the next row, it's again DA91 here. So basically, Git is keeping a track of where your head is moving. What are you doing here? So this was a commit. So it's like, okay, this is the commit. This is the commit message, and there are most of them are commits. Yeah, there's a rebase. There's a reset here. there's a rebase here, there's a rebase start, rebase finish. So yeah, basically Git is keeping these logs. These are the logs that Git maintains, and it sort of it's tracking the movement of your head, right? So same with refs, right? Let's just get into it. CLS, CB refs. Let's take the name for everyone. Yeah, CB refs, and let's LS here as well. Okay, so again, heads and remotes. Let's get inside heads. CD. Yeah. Now let's list it again. So yeah, again, 2 branches, right? So two files. Let's cat the main file, right? Again, it again same thing, right? So it's again started from cloning, committing, same thing. So basically, but this is maintaining the branch's status, right? So this is not tracking your head's movements, right? This is just tracking, hey, what are the changes you're making in your branch? So yeah, if it's an amended commit, like everything, every command you run is basically tracked by it, and these are the logs for it. This is where it does it. This is how Git reflog sort of collects everything. I don't know the logic which Git reflog uses to collect everything. I tried understanding Git logs logic, but it went right from here. So yeah, I don't know how it arranges everything in a proper line, but I've never explored that at least yet. But yeah, it uses these files here. This is where it stores its logs, right? So yeah, let's just move one above again. Yeah, so index done, logs done, packed refs, right? We did refs as well. So objects and refs are the only 2 things left, right? So great, let's get into packed refs, right? CB, oh, it's a file by the way. Cat packed refs, see, yeah. What's going on here? So basically, what's this file, right? So just imagine you are a repository like React or Vue, right? Huge repositories, right? They'll have so many branches, they'll have so many tags, they'll have so many remotes and everything, right? So the refs, so if you remember, refs has 3 directories in it: heads, the heads, remotes, and which one was it? Yeah, one more directory. So yeah, so all these tags, so just imagine how many of those React or Vue or someone will have, right? So storing those many files will affect performance, right? Because mainly you'll be using 1 or 2 branches at max. All the other branches are basically just occupying memory, right? So what Git does regularly, when it either garbage collects stuff, or when you're I think it does it while garbage collecting. I'm not sure, but yeah. So Git runs garbage collecting a few times. So what happens then? What it does, all the unused ones, right? All the branches that exist in the rest directory, it packs into one file, right? So instead of having a separate file for every branch and storing the commit in that, what it does, it gets the commit here, the hash here, and it stores the reference here, right? So no more files. So so that's why if you get inside the heads, you'll only see main, because main is the one I'm using, right? You won't see the GH pages branch. I'll show you. CD refs. So I'm in refs now. C ls. So you see heads here. If I cheat into heads and do an ls here, you'll see only main exists here. GH pages does not exist here. Why? Because when I had run garbage collection last or whatever, that time Git had packed everything here, and after that I've never used GH pages, right? That's why it has only main here. But if suppose I switch to GH pages, right? Let me try that out. I think it should work. So yeah, let's just see. So what will happen? So if I switch to GH pages, to the GH pages branch, right? What will happen? It will basically first come here to the ref/heads thing, because I'm switching to a local branch, but it won't find it here. So it will search. Oh, is there a packed ref branch? Oh, there is one. Okay, let's switch to let's get the head to this particular commit, right? So and it should also pop the file here. Okay, let's try that out. I hope that works. Again, one more level. Yeah, let's just try to, so Git branch, I am currently in the main branch, right? Let me just switch to GH pages. Git switch GH pages, right? Okay, fine, right? It switched to it. So now let's go and check the what do you call it? The packed refs file, right? cd.git, right? And cat. Oh, sorry, we have to check the refs folder. cd refs/heads, right? And if you do an ls here, it still has main here. Okay. Okay, let me try to pull. Wait, let me try to pull. That should do it, maybe. My bad. Okay. Let me try to pull the GHP zip launch. That might do it. Oh, my bad. Okay. Now let's try to check it. C.git slash refs slash heads. Finally. So yeah, and now if we compare, let's cat the GH pages thing. Yeah, so 8D2 right now, that's the latest commit. We just pulled it, right? And but if we compare it with the packed refs, it's still not going to be the what do you call it? The latest one, right? Yeah, if you see here, it's still on the older one, right? So it always first comes to the refs directory to check for the file. Okay, so it found it here, and yeah, whenever you pull it, it's going to create a new file, right? So yeah, that's basically the packed refs thing. It's basically packed refs file is basically created when you garbage collect and stuff. So Git will take everything in a refs directory, push it into one file so that it saves space, right? Whenever you check out a new file and pull the current changes, it will create that file again in the heads directory, because till then it's still at this commit, so it doesn't need to really create a new file there. If you add a commit or if you pull, as we saw now, it'll create that file over there with the latest commit, right? So yeah, that was the packed refs file. So if we so now the only things left are objects and yeah, I think objects. Yeah, objects is the only thing left now. So we'll get in that, but before
The
getting in
most
that,
the
any
most
doubts?
interesting part.
Yeah, that's the main crux of the entire talk. But yeah, any doubts before that?
First, I see one question in the chat, like what did the hash represent in the index file? So it is the
Oh,
commit.
yeah. That will come in the
Okay.
objects directory. I'll explain what a hash is and what that is, what's going on there, why is it required, what's going on, all that stuff. Um,
So
yeah,
I can repeat the question. So one question was like, if you change a file permission, whether that permission is also synced to Git. So like we saw that there is a file permission on the
yeah. I
Git
had to
directory
push it.
index.
I had to push it. Yes, I had to change it, and I had to push that file. So yes, changing file permissions, you do have to push it. I'm not really sure how that works internally, but yeah, you do have to push it.
Okay, so if anyone else is pulling it, then the same file
Yeah, the
permission
same.
would.
I'm guessing the same permissions. They'll also get the executable permissions. I think so. I might be wrong though. I'm making a guess, right? So I might be wrong.
Actually, I just tried changing the file permission from 644 to 400 chmod to 400. So it happens on my local. Am I audible? I hope. It only happens on my local, but it doesn't show up in the git ls file hyphen states. So the permission, and doesn't also show up in the git status. I think there's something else that you might have done in order to push that permission over.
Not really, to be honest. I had just changed file permissions. I had asked a friend, "Hey, what's going on? It's not happening." He's like, "Oh, you have to change file permissions." I just ran chmod, added the +x flag to execute it and to make it executable, and just pushed it after that. To be honest, don't really remember doing anything else to it.
Or the other explanation is those file permissions are cached, and so you have to clean it before you push it, right? After cleaning. That could be the explanation, because I did not see a change in its status in the moment I changed it.
Maybe, but I've done this twice before, so yeah, I've done it. I'm not really sure what happens internally, because yeah, rare cases. But yeah, anyone else? Anything?
Hello, am I audible?
Yes.
Yeah, Harsh, can you show me, can you go to again that part, like 0, 1, 2, 3, that, something you showed that.
Conflict. So whenever there is a conflict,
Yeah, exactly. Yeah, this one. So what basically you are saying that 0, 1, 2, 3, like how it represents? Like how did you identify that thing?
you're mute, Hers.
Harsh, you're mute.
sorry. So I read the documentation. That's how I came to know what each file is. Obviously, I wouldn't come to know. But yeah.
So basically, whenever there is a conflict, it keeps three versions of it. One is like I forgot the exact word for it. So one is basically for upstream or
Yeah, I'm just cutting that 1 second.
Okay, so like that, like one is for upstream, two is for downstream, like that.
Yes.
no,
So no, not downstream. So
One
yeah.
is like the original version, and the other one is like from the one
Yes.
you have conflicts with, and the third one is like both of them, like something like that, right?
Yes, you're right. So basically, all these three files have so all they have different things. So three will have your incoming change. One will have your base change, which you had in your local thing, and two will be the one which you will have showcased properly on VS Code with that nice GUI thing. That is the both files. It's called the hours file.
Okay.
Yeah, and three is called the diars file.
Okay, got it. Yeah.
I had a question regarding what happens after push. So locally we are maintaining this .git file. When we push a certain branch, does GitHub takes care of that Git file in GitHub repository, or like how does that happen? Is GitHub doing something there?
Of which file?
For example, if I'm locally, let's say I have created 4 branches, but I only push one branch, so I'm not really putting all of my .git directory in GitHub. There is just one branch going on GitHub. So
Yeah.
is GitHub maintaining that somehow? Is GitHub
So it
creating
happens.
.git file?
So you are not actually sending your branch, or your .git is not getting sent or something. There's only so it basically communicates through a pack file. So it basically sends that. So we're going to get into pack files. That's the last portion of the talk. So it basically sends that pack file to GitHub. Sorry. So that's how whatever you've done in that particular thing gets transported to GitHub.
Got it. Thanks.
So yeah, whichever branch you're in, that particular thing, that particular file is transferred, and that particular file has all the stuff in it. That what all that stuff is, I'll explain. But that's what is coming up.
but fetch works I think in a different way. Like if you just say
Okay, I
git
don't
fetch,
really.
it tries to fetch everything. It depends on your config. Like
Yeah, if you just run git fetch origin, it will fetch everything. But if you run git fetch particular branch, it will fetch
Then
the
it will
particular
fetch
branch. Now, how Git stores that, I've not really explored that part of it. So yeah, I don't
I
have
think
knowledge of that.
in configuration you can mention that if you're fetching something, what would be your main ref you want to fetch, that you can configure on ref somewhere. I'm not exactly sure, but somewhere you can configure that as well.
Yeah, but I'm where does it store it, right? That's what I've never looked into, right? When you do git fetch origin, where does it exactly store all of what it receives from GitHub? I've never really looked into that. Should do that.
In refs, in
Um,
refs.
have you tried setting up your own server where you could push code through? No, so yeah, I'm going to do that this week or something. I found someone shared something with me. Hey, you can create your own gate or something. So if I like that, I will share that to everyone on Twitter. So yeah, looking into that. Yes, good idea. That was next week's plan, by the way. But yeah, because someone had reached out on DM. So yeah, if I like it, I'll definitely share it, Aditya. So yeah, anything? So because now is the main part of the crux of the talk, right?
Objects.
Okay, I think we'll start. Okay, finally, objects directory, right? Let's cd into it. Now let's just cd just for the heck of it. What it is, I'll explain in a bit. But yeah, objects. Okay, yes. Damn, right? So many things. And so yeah, random numbers and something called info, something called pack, right? Let's get inside this. They're direct. All these are directories, by the. Let's get inside this one, right? CD00 ls. Okay. Some more files. Okay, all these are files, right? If we try to get this file, let's try to do that. Ooh, gibberish, right? What's going on? What's all this? So these are basically your objects and stuff. So yeah, what's going on? We'll look into that, but not for now. So yeah, just wanted to show you, hey, this is what exists inside the object directory. This is basically where the magic goes on, right? So yeah, what's the magic? What's going on? Let's start afresh here. Okay. So this repository has no commits right now. Nothing git log. Yep, I don't have anything on my current branch, nothing. Okay. So clean repository. Let's start. Let's see what happens. Okay. Okay. So just to show you, cat.git. Oh, not cat. ls.git. Yes, I'm not I'm bad joke. But so yeah, just for your reference, this is what exists right now. Okay, there's nothing else here. Okay, let's get inside the objects directory as well. I should show you that as well. Slash objects. Oh god, I can't spell OGCTS. Yeah. Okay, only info pack exists. None of the other stuff, only this info and pack exists. None of the other directories or anything exists. Okay. So yeah, just for reference, keep that in mind. Okay. Now let us create a file, right? Vim file1.txt, right? No, I'll just create it now. Okay. So created this file. Yeah, we have one file here. Okay. Let's add this, right? So git commit. Oh, sorry. Git add dot. Okay. Now let's see this. So by the way, just to show you, git status -s. Yeah. Okay. We've added the file. Okay. Yeah. Now let's get inside this objects directory again. Let's see what's going on, right? Ooh, new file here. Right, new directory. Pehle only infant pack. Now there's this E6 file. Let's get inside that. Okay. So let's try to again ls inside /E6. Right. Yeah. So this one file. Right. So again, let's try to cat that file now. Oops, wrong place. Again, gibberish. What is going on? So okay, so why is the gibberish, right? So the answer is basically that Git is doing compression, right? It won't store everything that you give it just normally, right? Otherwise the size would be crazy, right, of that .git thing. Just imagine pushing literal text from Git, your repository, to GitHub, right? That's crazy. Bandwidth goes brr. But anyways, so what goes on, right? It's compression, right? So we need to decompress it, right? So Git uses the zlib library to do this decompression thing. So OpenSSL has it here. So we are going to use OpenSSL to decompress that, right? Zlib library, obviously, but it's provided by OpenSSL. Zlib. Right, and now if we paste the path, we finally have something here, right? We have this blob and it's 0. So that's what this gibberish is, basically blob 0, right? Now that's not really clear. So to make things clearer for you, to understand things better, let us add some text in that, right? Yeah, let us get inside Vim txt. Let's insert stuff. Let's add. Okay, let's not do it this way. Exclamation. Q exclamation. E. Okay. Anyways, so yeah, let's echo it inside. Okay. Okay. Adding it to show you. Okay. This is what it has, right? Now let us add this again. Okay, because obviously if you don't add it, then Git doesn't know it exists, right? So right, it doesn't. It's modified, right? So let's add it again. Okay, file is added. Okay, now let us go and check what happened again. Let's check the that directory again. I'm just going to do it here as well so that it's easier for us. Dot slash. Open the same file here. cd.git slash objects. Okay. So we're in the object directory of the same repository, the Git internal repository, right? So we're just going to do ls here. Ooh, there was E6 initially, now there's one E. Okay, let's check what one E is, right? Again, obviously it's going to be cd1e, ls, it's going to be one file here, right? If we cat it, again, it's going to be gibberish. So we've got to decompress it.
By the way, Harshi, you can just do git space cat file.
Yeah, I'm getting to that. Decode it and in this particular file. Okay, so this is what it printed out, right? Now, what is going on here, right, in this file? So what it did, right? It basically said, okay, blob, then I write a space, then this 19, then this, right? Okay, so let's start. So blob is the object type, by the way. So whenever Git is storing some content, right? Whenever you're adding something, so basically you're adding files to Git, right? That means it is storing content. Okay, that's why this is the blob object, right? Now, when you have 19 here, what is 19? This is the length of your content. Okay. Then here there is a null character which you can't see. I'll prove that there's a null character. Just hold on. Okay. Then here starts the content. Okay, let's start counting. That this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, wait, that should be 18. Wait, what? 1, 2, 3, 4, 5. Okay, it's 17. Yeah, so it should be 18, but okay. So why was 19? But yeah, so one reason for it being extra is that there's when you echo something into a file, it adds a \n at the end of it. Okay, so basically what Git is doing, it's saying, okay, this is the file type, this is the length of the content ahead of it. It adds a \0, there's a null character here, and says, okay, what was after the null character is all the content of the file, right? So that's how it's structured. Okay, so now I'm not going to sort of do this whole command every goddamn time, right? So Git has provided another plumbing command for that, the one that Sudhanshu mentioned. That's called the git cat file command. Okay, I pretty print that. So P stands for pretty. It has 2-3 variations that I know of. P stands for printing it, pretty printing it. P stands for the type, and S stands for the size. So let's just print out the type first. And so, by the way, if you noticed, I forgot to show you something, and my bad. So we did add this, right? Oh, no problem. I'll show that later. No issues. Okay, so let's do this 1E and 868. Okay, so what I did, the file name, which is 1E, the folder name, then I added this 868 in front of it. Okay, let's see what it says. Okay, so it's saying this particular thing. Why did I include 1E here? I'll explain to you later. Just remember that for now. Okay, so 1E, this particular object is saying that, okay, it's a blob. Okay, so it's a blob that we had seen already like this in the file. Now, if you pretty print it, it gives me the content of the file, which is Git is amazing. Okay, now so yeah, that is basically the thing. And yeah, proving to you that there's a \0 here. It might not work this time, but let's try it out anyways. Okay, let's do this in F. Log 19 \0, as I said. Then again, I have to escape this obviously. Git is amazing. Escape this and \n here. Okay, I don't need the packets here. If I output that to SHA and sum, I'm not sure it's going to output the same one, but 4EF, yeah, I cannot put the same one. My bad. So basically, if I were to done it properly, I don't know why there's an extra one right now. Maybe if I try it on a new object, it might work. Let's try that out. C dot dot
slash r slash n. So Aditya mentioned slash, Abhishek mentioned slash r slash n could be there.
Sorry? Oh, slash n. There must be two of them. Okay, I'll try that.
Slash r slash n.
Oh, slash r slash n. Oh, okay, the CRLF thing. E93.
But
Okay, is it?
yeah, anyways.
All of them.
There's an exclamation.
Oh yeah, that is missing as well. My bad. Oops. It is amazing. 7C. Nope, it still gives the wrong one. Let's try some other combination. Maybe that works. CDC, right? We are looking for 1E86. Nope, I'll have to create a new one to show you. One second. So yeah, let's create a new one. Cool. It not equal to it is good, I guess. Or git good, yeah, git good. Git good. Yeah, let's echo that inside file2.txt. Okay. If we cat file2, yeah, git good. Okay, so that should have created one more object here. cd dot dot cls ls. Yeah. Oh, I didn't add that. My bad. Git add. Okay. Now it should have created one more. Yep, 0c, right? Let's see if it works out. Not sure. cd 0c. Yes. Yep. We need to create, yeah. Printf. Oh, I need to. My bad. Git cat file -p and give it 0c. Why am I giving 0c initially? I'll tell you. Give me a minute. Right. Yeah. Now I also need to cat it entirely. And I need to decompress it to get that final string. Oh my bad. I need to get the entire file. Okay, I got this. 1, 2, 3, 4, 5, 6, 7, 8. Again, 2 missing. I don't think it's going to work out this time. I'll have to figure out why. But anyways, moving on. Yeah. Okay, so basically what happened was that we created this stuff. We used git cat file to see, okay, there are blob objects, right? We saw the contents of blob object. It's basically blob space, the length of the file, \0 to give it the, what do you call it? The length of the content ahead. And so yeah, length of content \0 and whatever follows after \0 is basically the content of the file, right? So that's how Git stores your blob objects. Okay, I would have loved to show you back that when you do SHA-1 on that again, it comes back to the same SHA, but I wasn't able to demonstrate it right now. Yeah, so that's the blob objects. Now, how does this work with commit and everything, what's going on, right? So I've added these 2 files. So for now, we have these 2 files added in our repository, right? So let's commit them. So git commit -n, right? Add file1.txt and file2.txt, right? What we did, okay? We did this. Now, if you go and check again, FF, right? This is the new one. So if we see here, 2, 3 things happened, right? what happened. Okay, so Git gave us this particular thing. Now what is this thing? Someone asking what that hash stands for, right? So yeah, let me show you. Now let us do git log and see what's going on. Okay, so this 40 character, so this string that you see here, if you see, this is the first 7 characters of this string here. So what's going on? This is a 40 character string. It's the hexadecimal string. It's a SHA-1 hash, right? So it's basically nothing other than a unique identifier for the commit, right? So in databases, you have the primary key, right, which is unique for all rows in the table. That's the same thing here. So this is a unique hash. As is the 40 character thing, hash collisions are very rare, but they have happened happened a bit. So sorry.
I think this is a hash of a commit file.
Yes, get into that. So yeah, so basically hash conflicts are rare, right? Because it's a 40 character string, but it has happened before. So Git is planning to move on from SHA-1 hashes to SHA-256 hashes. So that is what you can expect to in the future, right? Now, how are these hashes generated, right? These 40 character unique things, how are they generated? So if you remember when I had cat the file, any one of the file, if you remember that entire blob 19 \0 and the entire content of the file, so Git takes that input and hashes that, right? And that is how you get this particular hash, okay? And after it creates this hash, what it does, it basically compresses all that content using zlib and stores it in a file, okay? So create that thing first, count the length, okay? Say blob space length of file \0, add the content there, create a hash of that, okay? Take a note of the hash and then compress it with zlib and store it in that file, okay? Now the file name, how do you name the file, right? So if you notice, E0 and then 38 characters, right? So 40 character string, take the first 2, split it, and the rest 32. Okay, so just remember E0 and CCA, okay? E0 and CCA. Now, let us go here. If I list it again, you'll see E0 here, right? So if we cd into E0 and we do ls, we see we have CCA, right? So what Git does, it basically buckets everything, right? This is called bucketing. So what it does, it takes the first 2 characters of the string, of the hash, and creates a directory out of it. And whatever is the stuff after it, it names the file after that. And whatever compressed contents that we had, it stores all of that compressed content in a file with these 38 characters. The name of the file is this 38 characters, right? Now, why is this required? Why is this bucketing thing required, right? So as you can see, if I just I list the number of files in the 001st directory here, you'll see there are so many commits with the same first 2 letters, but so many different files inside, right? So just imagine there are 424 commits or something in the Git Basics repository. So just imagine 400 files there. Whenever you want to look for a file or something, your OS has to work that much harder, right? So if you imagine a file, if you get Reacts or Views repo again, right? There must be so many objects there, right? So obviously all file systems have a limit to the number of files in a directory. Also, if they don't have a limit, then your performance starts getting hit, right? Just imagine searching for files in, searching for one particular file in like thousands of files. So yeah, that's why bucketing, it makes it easier for the OS to access your files, right? So that is why Git does this bucketing concept, right? First 2 directory name, rest 38 characters, file name. Okay, and inside the file stores the compressed stuff, right? So now what we saw initially were all blob objects, right? So now this is a commit object, right? So again, we are not going to use zlib to decompress stuff. We are just going to use a plumbing command that Git provides called git files. Git cat file. Let's pretty print it. Let's first see the type. Okay, let's just take the first. You don't need to use the 40 characters. You can just use the first 3-4 characters, right? Okay, so file type is a commit type. Okay, let's print it. What exists in a commit object, right? Okay, so we have something here, right? So we would have got this almost the same output. We would have got if we would have used zlib to decompress the file. We would have got commit space the length of this entire content \0, and then finally all this content in that file. Okay, but we're using this to make things simpler. Okay, now. So Git handled the decompression and removing all the content and everything, just displaying the content, okay? But anyways, so now there's some tree thing here. There's another hash here. There is the author, committer, and the commit message. If there was a commit description, it would have appeared in the next line, right? So Fine then. Basically, there is one more thing here. We're going to get into this. Obviously, this is our other object, the tree object, right? But before that, let's just get this. This is your author, whoever has written the actual code in the commit, and your committer is the one who actually pushed it and committed it. Author and committer can be different. This happens sometimes with me, wherein one of my friends makes some improvements, and they're like, hey, I don't want to open up pull request right now. Just take this patch and push it to your commit it to your repository. So I take the patch from him, which is basically a commit, but I commit it into the repository, right? I commit that file into the repository, that patch file. So what Git does, the author's name will be that friend's name, the other person's name, but the actual committer will be my name because I committed it, right? But actual code was written by someone else, right? So that's why there are these two different things. Then there's a commit message, obviously. Okay, now let us get into this. So till now, what have we done? We explored bucketing. We've seen how Git internally compresses objects, and before compressing them, it puts them in a particular format, and then it generates a hash from that format, then compresses that and puts it in the file, right? That's what we've seen. We explored the blob object, we explored the commit object, right? Although it's not complete yet, we've explored half of the commit object. Okay, so now let us go and explore this tree object, right? Let's explore what this particular file has. Now you know that this is going to be a file here. There's going to be a directory called ff, and then there's going to be a file called f66 inside it. So obviously here, if we see, there's a directory called ff here. So let us cd into ff. Okay, that is ls here. So yeah, f66. If you see here, ff f66, right? So yes, let us again get cat file it. Get cat file -t. Yes. Oh, sorry, my bad. I need to add in the first two letters as well. FF, right? Yeah. So tree. By the way, FF, I added these two characters because this is incomplete, right? So yeah, it gave me tree, right? Now, if I pretty print this, now this is where again new things pop up, right? What is the content of this tree file? Okay. It is pointing to blobs. Okay, so if you're understanding what is going on, there was a commit created. Okay, the commit had a reference to the tree had a reference to the blob, right? So that means it is sort of creating this connection, right? If you imagine it. So what's going on? Again, this is the mode of the file. The first two bits are indicating the type of file, unused number, then not bits number. The last three numbers are file permissions, type of object, and why is this type of object required here? And we'll get to that. That's one more scenario, right? The hash of the file and the name of the file. If you noticed, when we opened the blob file, there was no mention of the name of the file, right? So a blob object does not know the name of its file. The name of the file is stored here in the tree object. That's how Git knows that, okay, this is the name of the file, right? So yeah, this is your tree object wherein, so if you understand there's a connection being created, so to visualize that better, I created a utility called Git Graph. What it basically does is that it will take a .git repo. So let's just get inside Git internals and give it this .git repo. Let's select it. Okay, so the head is apparently pointing to this commit here, right? So let's just first see how it is pointing, what's going on. So yeah, let's come here. Okay, let's see what's going on. Okay, so if I run git log, you see latest commit, there's only one commit called E0CCA, which is E0CCA, right? Then apparently the head is pointing to this. So how do we check that? Here we can again cat the head file that will lead us to the main ref/head/main. We go to that file, but instead of that, again there's a plumbing command that Git gives you called git rev parse. Okay, rev parse, and what do you want to rev parse? The head file, right? Okay, so the head is pointing to. So basically, it just went to the head file, went to the refs directory /head/main, got the thing and showed it to us. So yeah, E0CCA. Okay, so head is pointing to E0CCA. Great. Then when we cat file the this thing, cat. Sorry for doing it again. -p. Yes. So if you see the tree FFF66, right? So FFF66 here. Okay, and now if we go here, oh god, I love clearing up stuff, don't I? Yeah, if we see, this is pointing to 1E86 and 0C5. 1E86 and 0C5. Okay, so Git is creating this kind of graph, right? wherein head is pointing to the latest commit, the commit is pointing to a tree, the tree is pointing to whatever blobs you have in your file, in your repository. Okay, so, and these are the names of the blobs, by the way, which the tree stores, right? The blob doesn't know its name. Okay, so we have this, right? Now let us add some more scenarios to it. Now, let us create one more commit just for the heck of it. Okay, let's see what happens, right? Okay, so let me create a new file again. I'm going to say vim file3.txt. I'm going to insert the internals. Okay, SQ colon WQ. Yeah.
So
okay.
there was a
Yeah.
question from Saurabh, if you can cover that part in this time. Basically, like,
if I have multiple files in one Git add, will it create multiple objects? I'll get to that. You'll see it here, right? Okay, if you want to see it here, you can. Sure. So let's create one more file, right? Saurabh was telling me to create one more file. Let's create file 4 as well. Okay. Let's insert Saurabh's name itself. EAWR, yeah. We have two files. So git status to show you. Two files, okay? Now let us add it, git add. Okay. Now if we check git status, both are added, right? Again, git commit. If I'm coming to your question, sorry, one second. Okay, add file 2. Sorry, what was it? File 3. File 3.txt and file 4.txt. Okay. Now if you go back to our graph again, no, let's not go back to the graph. I'll show you why. I'll tell you why. Give me 1 second. I'll come to your question, Saurabh. So let us, just for the heck of it, let us try to again cat file this. Okay. This is hash of the commit, by the way. Okay. So if we cat file this, paste, okay. Oh, there's a parent line added here, right? Initially it was just tree, author, committer, and the message, right? Now there's a parent line added here, right? And if you see here, if you run git log, you'll see, oh, this was the initial commit, this is the next commit, and this next commit, which is C63. When we cat at C63, we have the parent as E0CC, which was the initial commit, right? So that means your so the first commit, it does not have a parent, right? Because the first commit. That's the, if you remember in log, you'd seen that 0000, that's the 0000, right? It has no parent. So now this one has a parent, right? So now let's see what the connection looks like, right? Let's choose it again. Yes. Okay, things are getting slightly more complicated here, right? So, okay, so as we saw, this is the latest commit. Again, if we do a head ref parse, the head file is pointing to C63, right? So C63 is pointing here. The parent, which was E0CCA, is E0CCA, that's the parent, right? And now this is the tree object this is the new tree object that was created, right? The D8 one. See, this is the new object, and D85, right? So D85, new tree object was created. So we did not modify file 1 and file 2, right? So it is just directly pointing to those same files. If I cat the tree, cat file, where's the tree? Yep, this one. Paste. See, file 1, file 2, 1E0C. Okay, 1E0C, same files, no change. It is still pointing to that. If you see this green arrow, this one and this one, right? I'll just do it again so that the colors might change. Better. So if you see 1E and 0C, this blue and yellow arrow point to the same files. Now Saurabh told us, let's add 2 files. We added that. Okay, so it was added, Saurabh. That's what you wanted, I guess. So yeah, this is how it's going on. Let us add some more complexity, right? What if we have a directory, right? We create a directory. How does Git handle directories now? Okay, so let's go back to the command line. Let's clear everything. I'll select it for you. So we have 4 files now, file 1, file 2, file 3, file 4. Let's add a directory. Okay, dir1. Okay, a directory, let's cd into that directory. Let's create a file here. Then dir1 file 1.txt. txt. Okay. And insert inside dir1. Okay. Escape colon wq. Fine. Now, so yeah, we have this, and if we go back, we have the directory one here. Okay. Now, what is going on here? Let's get status. We'll say, okay, directory one, I don't know. I'm going to add it. I'm going to commit it, right? Again, adding will create an object there and stuff like that. Okay, we'll see what's going on. Okay, git commit -m add dir1 slash dir1 txt. Okay, added that. Okay, now so we have this one here, right? C86. Let us see that. Git cat file -p C86. Right, we have this. Now we get the tree here, right? Obviously, it has the parent, which is the previous one, C631. Okay, now let's get the tree. Okay, let's copy paste that. Okay, so now you understand why you require that tree, right? Why you required Git to write down the file, the object type here, because this tree is pointing to another tree, right? All the other files are unchanged; they are the same blobs and everything. So yeah, that's going on. But also, if you see here, this has changed. These are normal files, the directory. So this number has changed again. Again, file permissions also changed. I do not know what that means. Do not ask me. But yeah, okay. So we have another tree here. Let us cat file this tree. Git cat file -tree. Okay, again, so finally this tree has our particular file, right? I think you're understanding what's going on. So commit pointing to tree pointing to all the files, and if there's a directory, it's pointing to the tree of the directory. Then that directory is pointing to all the files inside that directory, right? So again, if you want to view that, let's do that, right? It's getting a little complicated, but yeah. So yeah, again, this is the latest one here, C86, if you remember. So yeah, C86, C63, C86, C63, right? So now, again, this tree is pointing to the same file 1 to 4. It's pointing to the same files, right? And here we have directory 1 that was there. So it has a tree of its own, right? F2E6. If you see here, F2E6, right? That directory 1. So again, this tree and this directory is finally pointing to this blob, like we saw here, 7052, 7052, right? So this is how Git is handling directories, right? So yeah, also if you modify any one of the files now, a duplicate will be created with the same name, but a different hash, right? Because the content has changed. If you remember how hashes are generated, it's the blob space file length and then the content of the file, right? So that differs. So that's why the hash generator is going to be different, right? That's why it's going to be a new blob object. So yeah. Any questions till now?
So one interesting thing comes here.
Yes, Ganshu.
Yes, so like basically the Git commits are not just pointing the difference; it's pointing the whole snapshot at that moment of time. Like
yes, your tree holds the snapshot. So tree is actually holding the snapshot. What you're talking about. Commits are basically it's just pointers. Commits are literally just pointers. That's it, and has some extra information about authors and committers and the commit message. But other than that, the main use is like okay, pointing to this and pointing to this. Also, if you notice here, this is sort of a graph, right? So if you see, there are no loops anywhere. Like no commit is like blob is not pointing back to the tree, or there is no cycle going on. Even this is just like this. There's no blob coming back to this tree, right? So basically, and all the files are like there are arrows, right? Everything is pointing to something. So basically, the graph you see here is a directed acyclic graph, right? So Git creates a directed acyclic graph to connect all your objects together, right?
What will happen if you put a Simlink inside which points to parent folder?
I'm not sure. Someone wants to take that up. Someone is obsessed with Simlinks.
But yeah, fine. Like
Yeah,
Pratik,
sure.
you
I
had
mean, if
question.
someone knows what happens, please let me know. I have not experimenting this much, ate my head out. So yeah.
Pratik, you
Yeah,
had.
I had one question.
Sure.
Yeah, like I was curious, like how does Git store like which lines have changed and which lines were like modified? Like whenever we modify a file, we can see like in which commit which lines were modified.
You are mute. Hers, you are mute.
Oh, sorry. I've not looked into that. Anyone knows?
The first thing, basically, like commit doesn't store the changes. It just stores the uh, pointers to file at that commit. Now, like when you see
Yeah, I
it,
got it.
that is a time where it gives you a difference from like a parent commit minus so it compares between whatever file status was there for parent commit and whatever file status is now.
Yes.
So
So it does not. It basically does not store the diff anywhere,
yeah,
right?
yeah.
It stores separate files. So and compressed, obviously. So now, if you want the diff between two, it will minus the files and show you the diff, right? And there's a nice structure for that as well. Recently read on Twitter, but yeah, I'll share that by the way if you want. It's an interesting read. I tagged Saurabh and stuff there, but yeah, I'll just share that with you. But in the meantime, any questions?
Saurabh have some question, I think.
Yeah, give me 1 minute. So I'm just sharing a link to Twitter thread. Just have a look if you are interested in seeing the format of the patch, right? How the patch is created. Quite interesting. What if you delete a file now? Will it delete blob? Um, so if I delete a file right now, it will basically just lose the reference to it. Okay, so Git will in that particular tree, it will just lose the reference to that particular block. That is what I expect. Right? Let's try that. Let's see how my thing handles it as well. I hope it doesn't destroy it. So yeah, it should be tried. I don't want to destroy it, but yeah, that's what I'm expecting. It will remove. Let's try it at the end of the thing. Remind me, Saurav, I'll try it because this was the creating Git graph was a pain, and I've not handled a lot of things, a lot of the errors. So let's not destroy the repository for now. We'll try deleting later on. Mostly, it's just going to lose a reference to that particular blob.
Yeah, so makes sense, right?
That's all.
In a tree,
the tree will just not have that entry. That's it. Does that answer your question, by the way, Saurabh? Great. We'll try that at the end. Remind me. I'll do that. Sure. Any other questions, anyone? I think we have, let me check. I think 2 topics left or something. Give me a minute. Objects. Yeah. We have three things left. So now let us.
I had a question. Like, has anyone used JIT subtree and JIT sub module? And just wanted to get any opinion if anyone has experienced both. And
what do you want to know about Git submodules?
I've used JIT sub modules, but not JIT subtree. So, but I've tried to read around, and I'm saying that many people say JIT sub module is problematic. Different things works out for different use cases. So just if you have any opinion on what you have tried it out and how it's worked for you.
I don't have one. I've never used it. Someone else?
No.
Do you have any experience with it?
No, like basically we were comparing submodules and monorepo ones, and we felt like a monorepo choice is better than going in a direction of a submodule. Submodules is just a pain. So I don't have much.
If you said you had some pain with submodules, but what exactly was the problem you faced?
No, I didn't face any problem. I just read about it and left it with that.
Okay.
So I took someone other's experience.
Okay, yeah. So I just wanted to get some to see if there's any first-hand experiences or what something, because I've used it very sparingly, so not hit anything because maybe I'm not mutating the projects enough. So maybe. Sure, thanks.
You're mute again,
Oh,
Harsh.
I'm on mute. My God, what time today? Yeah, so we have around three things left. That's around, I think, 20 minutes for. Sorry if I'm boring you, but yeah. So any more questions before we move on? Okay, fine. So now we're just going to get into one or two use cases, and then we're going to get into pack directory, right? That's one more that we're looking for. So the one thing that we're going to do now is we're going to see how Git handles rename. Okay, so let's just come into the previous one, right?
I'm
If you rename a file, how
I,
does that work out?
I'm not sure if it's
Nothing is
my
changed.
network issue or maybe Hertz from your end.
Just the file name has changed,
Yeah, it's
right?
breaking. Hertz, it's breaking.
Let's see how that works out. So yeah, yes.
I think your connection is breaking.
You can't hear me, or what's going on?
Yeah, it's breaking a lot. So probably you can just switch off your video. Maybe that if that helps. Okay. Um, so join back.
Hi, can you hear me?
Yeah, can hear you.
Great. Sorry for that. My bad. Entire screen. Okay. Yeah, really sorry for that. Okay, so we are done with the Git graph thing mostly. So now we are going to look into renaming a file. So the basic change we're going to make is that, hey, we're only going to change the name of a file. Let's see how Git reacts to that, right? So yeah, let's just rename file 1.txt to file.txt. Okay, so I'm just going to rename file 1.txt to file.txt. Okay. So if we ls now, so file one has been changed to file, right? So and if we do git status now, oh god, I can't spell ATUS. Yeah, finally. So it's telling me it's deleted and it can't. It's this file is untracked, right? So let's just add it. If you added it, oh, Git realized, okay, it's a rename. Okay, so let's commit it and see what exactly is going on in the tree and blobs and stuff, right? So yeah, git commit -n in file 1.txt to file.txt, right? Okay, now we got this. Now again, you know the ritual, git cat file paste. We get the tree here. So git cat file again. Okay, so okay, what changed? What happened? Okay, and we also over here. Let us get back into this comment, the previous one, right? I just want to cat that as well. Oh, yeah, and again. Get in the tree. So I went to the previous commit, I cat that, and I'm going to cat the previous commit's tree. Okay, and then we are going to compare the two. Okay, so this is the previous one, this is the new one. Okay, what's the difference, right? So F2 1 is 0C, F2 1 is 0C, 2825, and last one 2825. Okay, so blobs have not changed. Okay, what has changed? Okay, so DR1 file 1 file 2 file 3 file 4. Okay, that is the old one. Now DR1 file.txt file 2 file 3 file 4. So the only change during a rename was the file change, the name change. Okay. In the previous blob, it is still the same. Okay. and in the new one, the only thing is the file change. So now you understand whoever sort of thought of this Git thing, or I don't know if it's Linus who thought of it or someone else, but whoever thought of this basically said that, oh, okay, the file name changing, but the content is not changing. Why should I store that blob twice, right? So that's why file names were not included in sort of blobs, and trees were managing that, right? Because pointing to the same object, both of them are pointing to the same object. It's just the file name that has changed, right? That's that. When I realized, I was like, oh, that's so smart. So yeah, that is one thing I really liked. That this was thought about, that hey, just the file can change, and this doesn't need to change, right? So yeah, renaming Git handles it well. It only changes the file name and the tree object. The blob object remains the same, so that's efficient. Yeah, that covers the renaming thing. Now let us get into sort of large files, right? Let us see how Git handles maybe an image, right? Um, Okay, but before we get to that, that's another huge topic, that's getting into the pack file, right? Before we get into that, let's get into just stray away from the path and get into something known as empty commits, right? So if you remember, if you know this, Git allows you to make empty commits. So there are no changes over there. So the command for that is basically git commit allow empty -m, and you can add a message here. Okay, so basically what you're telling it, hey, allow this commit. There are no changes here, no files are being changed. Just give it this message, right? So Git allows you to create empty commits. Okay, so how does that work out? Where does the tree point then? What's going on? Let's try that out, right? So yeah, let's create a new repository. Just a 2-minute thing, don't worry, it won't take too much time. /git/workshop ADR test state C test 8. Oh god. Keeping it. Uh, uh, we just added hi there.
I have one small question. How does like mkdir is initializing Git in your system? Have you?
What? No, it's not initializing it.
It said.
I did get it.
Oh, okay. Sorry.
Yeah, no issues. Okay, so Git, I added the file I committed. Right now, so yeah, again, let's go to the graph. Git workshop test 8 Git file directory. I mean, new files. Okay, one commit, tree this, blob this, file1.txt, right? I know, God, can you please hide? Yeah. Now let us create empty commits. Let's see what happens. Git commit. And let's do one more just for the heck of it. Okay. Now let's see what happens to the tree. How does Git handle that? Okay, pretty straightforward. Okay, 310 was the head was the first commit, right? 310 initial commit, right? Then we had
Hurts, you are breaking again.
ED4.
Hurts, you are breaking again.
Yeah, now it's still it's a little choppy, my bad.
Yeah.
Can you see this?
Yeah, we can see. Just keep your video off, so probably that would. Yep, we can see this. This is
Okay,
better.
great. So yeah, basically, this was the head commit, right? Sorry, my bad. The initial commit 310, as we saw here. The initial commit was 310. Okay, then we had empty commit 1, which was ed, right? So empty commit 1 ed, empty commit 2 0d. Okay, so this tree was basically created by the initial commit, right? And which had this file. Now these two commits, which were empty commits, just pointed to the tree before them, right? So the tree before this one was this commits tree, its parents tree, right? That's why it pointed here. Now this commit searches for its parents tree. Okay, which is the parent tree? This one. So it points to the same thing, right? So commits basically just point to their empty commits just point to the previous tree. Now, one question that you might have here is, what if an empty commit is the first commit in a repository, right? That's a valid question. So in that case, that is the only case where an empty commit object can point to its own tree, right? Right now, these two don't have their own trees; they're pointing to their parents' trees, right? So if an empty commit is the first commit, it will have its own tree, which will be an empty tree. So there just won't be nothing after this, right? So yeah, it'll just point to an empty tree. The tree will just have tree space 0, I guess, and \0. That's it. No content after that. So that will be an empty tree. So yeah, that was just empty commits. So I think that should be pretty clear. Just a small detour. But yeah, now let's get on to the last part of everything, which is, oh, that's perfect, 15 minutes. So yeah, last part of everything, which is how Git handles huge files, right? Again, interesting topic here. Lots to learn. Yeah, let's get in that. So here is where you learn about this info and pack thing, right? I had not explained what this is, right? So we'll get into this now. So by the way, initially in the .git directory, only objects was left. Now you know how this entire objects thing is working. The only thing left now is these two directories, right? What's going on here? Okay, we'll explore that now, and then that will complete the entire .git directory. Obviously, we did not get into rebase, merge, LFS, or anything like that, right? Just the basic stuff. Okay, let's do that. We'll have to search for an image pic for that. Okay, let's search for an image. Pictures. Let's take this one. Okay, so we take the picture, we paste it in our Git internals thing, right? Let's do it in the new one that we created. Okay, let's do it in another one. Okay, fine, test 6. Let's use test 6. So yeah, current way in which test 6 looks like, I'll just show it to you. Purposely choosing another one so that we have the reference of the previous one still, because once I get into pictures, my thing gets destroyed. So that's why using a different. So it's the exact same structure, right, as we have for that one. Fewer number of files. That's it. Okay, great. So we are going to add a picture to this one. Okay, yeah, let's see. So I'm going to paste it here. Okay, we have this picture here. Great. Let us navigate to that. cd.6. Great. Okay. So dir index.html style.css as listed here, index and style, and this dir, which has the script.js file. Okay. And now we added this particular thing. Okay. Image. Now that is again, first step is always normal. Let me log the file here. Okay, just to show you. Okay, 228 is last commit, and now we're just going to run git status, and git is going to show us, okay, fine, you have this unpacked file. I'm going to say, okay, git add, and hey, please commit it now. Okay, fine. Commit done, stuff done, right? Now let me just check this. Okay, I need to find the blog for this. Give me a minute. File. P. Okay, P. One minute, I'll explain what I'm doing. 5F, right? 5F. Yeah, 5F. Great. So if you see here, I forgot the full form of div hyphen C. What it does, it basically, so this, what you can see on the left is basically in KBs, the size of the file or directory. Okay, this is the size in KBs. Okay, and this is the part to it, obviously. Okay, so this 5F directory, and if you see the blob for the image, it starts with 5F, right? So this 5F directory is the largest directory for now, right? Okay, and yeah, this is the objects directory, which is 72, and out of that 72, 56 is made up of this image. Okay, now let's make a small change in the image. Okay, let's, obviously we're going to corrupt the image, but we don't care, right? Okay, insert, I just add a dot at the start of the file. I say escape, I say save and quit. Okay, so file is corrupt now, but we don't care. Okay, git status. Okay, we modified the image file. Okay, we're going to add it now. Okay, now git again commit it like usual. Oops, I don't. And paste. Yeah. Okay. Again, let's run. I'll have to. Sorry. Yeah, let's just run du hyphen c. Let's see what happens. Okay, we have. So we had this 5F initially, which was 56 KBs. Now again, we have this C4, which is again 56, right? So you must be thinking like, this is 56 KBs, but what if I had a 1.5 MB image or something, right? What will happen then? What the hell, Harsh, right? So yeah, right now it is very inefficient, right? But obviously this is just locally in your local machine. These are called loose objects, right? Just stored like that. Now, how should this be stored properly, right? So here is where the pack file comes in, right? So if you see this pack thing right now, pack and info, their size is 0, right? So let's pack it, right? Let's pack a repository. So if you remember initially, even when I was talking about packed refs, I talked about my camera's not on. Yeah, I had talked about basically info and pack, and sorry, told you that hey, when you run garbage collection or something, Git packs everything together and stuff, right? So what's going on? By the way, even when you push Git pack stuff to push, sort of that you had asked that initially. So yeah, let's just do that. Okay, Git GC, that's garbage collection and aggressive. Okay. Let's just do that. Let's see what happens to all this stuff, right? Just remember this 56, 56 and 0 over here, right? Let's see what happens. Okay, see, it tells me it's doing delta compression, right? Okay, we'll get into that, don't worry. So, yeah, now let's see du-c, what's going on, right? This is interesting. Okay, now my objects directory, apparently all of these have disappeared somewhere. Again, disappeared. And if we check the info and pack, look at the pack file. It's still like, 64. Initially it was 0, right? Now it's 64. Info was also 0, it's 5 now. And if you see, there is no other object here, right? All the objects have disappeared. Okay, all these 93, all of these objects have, basically all of this has disappeared somewhere, right? Okay, so what has happened now? What has happened is stuff has gone here. Let's check out what's there over here. Okay, if you copy this, if we get into .git, okay, cd objects. By the way, you can see the objects directory now. Yeah, it's just these two things, nothing else, right? Let's get inside the pack directory. I'll explain index as well, don't worry. Okay, let's ls. Okay, there's a pack, some hash .idx. IDX stands for index. Pack something, again, same, by the way, same file, just .index and .pack, right? Now, what does this have? What is this, right? So the pack file is something I've not really looked at the output, but I'm sure there is a way to decompress it and stuff. I'm not really looked into that. But what I'm going to show you now is basically what it contains, right? So there's another plumbing command called git verify pack, right? So verify pack -v verbose, and I give it the name of the file, the pack file, right? Okay, so it's telling me the pack file is okay. I just needed to verify it. But now what's going on here? Like what's there, right? So let's see. These are all the comments. These are the blobs. There are some trees. There are blobs and stuff. Okay, so if you remember, the initial image was 5F, right? When we had initially added stuff, it was 5F which had 56. Okay, and then later on, what happened? 5F was still there with 56, and then we had C4 coming, right? Okay, so let's check out. C4 is the latest version, right? Because it modified it. So if we search for C4 here, C4, yeah. If you see this, and by the way, this column here is giving the size of the file. So if you see, this is the largest file here, right? 73,000. I think it's, I don't know the year, but this is the largest file here, right? If you see this, I think it's the second one. 56 is closer, but I'm not sure. But yeah, so basically, or maybe I'm wrong, but yeah, so this is the largest thing here, right? 73,000, right? So, and this is the C4, which is the latest modified version. Which was the initial one, the 5F1, right? But if you check here, it's just 13. And if you see here, it has C4 written here. So what Git did, it realized, okay, this file is huge. Let's do this. Let's keep the latest file, and with the original file, let's just store the diff, right? And this is only happening in the pack file. Please do not confuse it with the blob object. Your blob objects never store diffs, okay? So Git is not storing your diffs anywhere else, okay? With objects, Git is if you want the diff, it minuses it and shows it to you. But here, when you have such huge files, okay, when you have huge files, what does Git do? Git says, okay, usually people will access the latest file. So let us keep the latest file in its entirety. But for the previous one, the older versions, let's only keep the diff, right? Because this pack file is basically what Git uses to push stuff and that kind of stuff, right? So it has to be small, right? It has to store, has to make the thing as small as possible. So what this particular pack file stores actually stores all the objects in one file, right? And here it is only showing the entries to these files, right? So what's going on here is basically that it's a graph in itself, right? These things are a graph in itself. They're pointing to different things, right? So yeah, that is basically the point I wanted to make. C4 is the latest copy, which is the largest. F5F is the oldest copy. It's small. It has got a parent here, which is C4, the newer version, right? So Git is saying, okay, if you want to create this file, you go to this and diff it and do whatever you want to, and you can create the older one, right? So this is the file. Now this is the pack file which stores all the objects together, right? All the if you remember the thing, right? Object type, length, \0, content, right? Everything is stored in this one file. I'm not exactly sure of the format in which it is stored. That might be a little different, but yeah, all the objects are in this file. Now, why is this index file required, right? So this index file basically gives you the offset in this pack file. Okay, if you want this object, okay, find it in this particular position in this pack file, right? So the index file gives you the indices to the particular offset to the particular object. And the pack file contains all the objects, right? So I think this answers the question that what happens when you push and stuff, like how does that go on? So yeah, this is one way where Git intelligently handles your pushing and pulling and saving data there, right? But still, remember, it's in blob objects, we're not diffing stuff, okay? It stores entire files.
So does it unpack when it reaches to remote, or it will just restore the
I
pack?
don't know how remote handles it, but when there is a command to locally, at least, to unpack files. There Git unpack file or something like that. I've tried it once or twice. It didn't really work out, so I'm not sure how that works. But you can unpack it, and there is a command for that, Git unpack file. And I don't know if it creates again two loose objects like we saw here, wherein it has this and this like this. I don't think it will create that, but I might be wrong, right? I've not seen that output. So yeah, just wanted to show you what the pack file is, what it does, why is the index file required. And this basically covers like all the basic files that you wanted to know. Now I just wanted to show you. So Git Basics is the repository that I've been referring, right? It's basically a project that I made to sort of document all of my knowledge stuff. So if you see this Git internal section here, whatever we did today is all noted down here. Okay, all files directories, everything that I explained to is noted down here with examples and what's going on, explaining each and every thing that I told you here. So yeah, feel free to go through this. Also, I wanted to show you, yeah, for the directories that we covered today, we did not cover quite a few of them. So we did not cover add p thing. So this is when you use the git add command, git add hyphen p, I think, to add basically just hunks of files. So this is that div file. We saw commit edit message, we saw config, we saw description, we saw fetch head, we saw head. Let me describe it, yeah, because you might have forgotten. So commit edit message is basically wherein you write a commit message. Config is where you have your local git config and your alias is stored. Description is not used now, it was used during Git web days. Fetch head is where your remote, when you fetch something, what is the remote latest remote commit you locally have, it keeps a store of that. Okay, head is the points to the latest commit in the branch. By the way, it will always have barring one exception, it will always reference the rest directory. The head file will have a hash in it only in the case of whether only when it is in a detached head state. What is the detached head state? It's basically when you checked out a particular commit, right? When you say git checkout and commit hash, at that point in time, go and check the head file. You will see it has a SHA instead of a reference to that refs directory, right? Just forgot to mention that initially. So we saw the hooks directory wherein you can talk about where you can add in pre-commit hooks and stuff like that to check stuff. Index file we saw, that's the important file. Your staging area is your index file. We saw include info where we went in the exclude file, which is your local.git ignore. We did not get into LFS. I myself don't know much about LFS. We got into logs wherein we saw, hey, Git keeps a track of everything you are doing, whether it comes to heads or it comes to the local branches that you have, right? We did not get into merging stuff, right? We got into objects, the most important thing here of the entire talk. We got into orig head, which stores the commit of the last commit where you had made a destructive change, right? We saw packed refs when you garbage collect and stuff. Nothing should be there in the refs directory and stuff, and you should only it pushes all the refs into one particular file. So that's there. Then we did not get into rebase merge stuff because rebasing is something I myself don't understand very well. I've done it quite a few times, but it's still complicated for me. Refs is what we saw again. This is what stores the latest commit for each and every branch or whatever. One thing I did not talk about is when you stash something, that is also the reference to that object is also stored here. It's a commit object. So yeah, you can have a look at it. It has its own tree and stuff as well. So yeah, when you stash stuff, the commit which the object is stored here. Okay. So yeah, by the way, I just wanted to, so yeah, that was basically us exploring this entire directory and getting into objects and looking at tree, blob, commit objects, different things and that kind of stuff. And last thing I wanted to show you, I just remembered packed refs. We just garbage collected this particular repo, right? So we should go and check the packed refs file. I think it should have been created, I'm not sure. Let me just do that and that should end the talk. ls, yes, there is a packed refs file, if you see. Initially it did not exist. I'm sorry I did not show you that. Cat packed refs. Okay, it has main here. Let us go and check the refs directory. cd ref/heads. That's empty. It does not have the main directory reference right now, right? Because why it packed it here? Okay. Now, if I create a commit here, it will appear here again. Okay, but this it will still have this old one here. I'll just show that to you as well. Okay, let's just make a random empty commit again, right? I hope that does it, by the way. Empty commit -m. Now let us check the refs directory. Why did I press that? c.git/refs/head. Yes. Yep. Now main is here, right? And if I cat main, we have 9.1e, which was this empty commit, latest commit. And but if we still cat packtrace, it will show the older one. I want to show you that. Yep, 7FA. It's still on the older one. Okay. So yeah, I just wanted to show you that, and that sums up everything that I wanted to tell you. So yeah, open to any doubts, discussions, and whatever you want to do now. So yeah, thank you so much. You can find me at harshkapadia.me. I'll just paste a link in the chat. By the way, first of all, let me paste a link to Git Basics so that you have all the references to what you need basically. So yeah, that's Git Basics for you. If you need Git Graph, that's Git Graph. By the way, Git Graph has a lot of problems. Git is very, very complex. I have not handled a lot of scenarios. So yeah, a lot of scenarios are still remaining. Planning to upgrade after talk. Okay, so that was that. And if you want to connect with me, I am, I can be found at, I can find my own domain. Found it. Yeah, this is the link. And if you want all my links, you can go to this one. And yeah, before I go, I also run a community called OTC, our tech community. And tonight we have a another session. Every Saturday night we hold a session. So feel free to join in. Interesting talk start off at 12:30 a.m. So 12:30 to 3:30 a.m. in the morning is when we have really intense talks. So starts at 10:30, but feel free to join in whenever you want to. 12:30 is when the interesting stuff starts. So yeah, I'll just share a link to that as well. Feel free to join in. You can read our summaries as well. We've had a lot of good sessions. So yeah, really the 63rd session. We've been going on for 62 weeks uninterrupted. So every Saturday night is where we meet. So yeah, feel free to reach out. Feel free to ask any doubts now. So yeah, thank you. And that ends the monologue.